Hello friends, welcome back. This is Sanjay Kumar Adhikari and today we will continue with our Linux file system, and please subscribe to YouTube channel Embedkari for further discussion on embedded systems. I recommend to use laptop or PC with headphone or at least tablet for watching related YouTube video. In the last blog, I discussed about LSOP and PS process status commands. And you may notice here I am, uh, using some sort of color coding like green color for certain commands. So, it means that these are the frequently used commands, and other is LSOP is useful, but not that frequently used command. Okay, so eventually we will have a list of frequently used commands. So I strongly recommend you to read earlier blog, for better understanding the flow I'm using here. And if you find something missing, please provide feedback in comment box so that I can take corrective action. So today I will be using that important aspect of redirection that will be used, normally in your bash shell scripting, and as well as that will be in your day-to-day searching related operation and any kind of. So last time in the blog I discussed about redirecting the output and redirecting output and append. So these things. So let's see that how it happens in a simpler way here practically. Let's say if you want to simply echo something, let's say hello, or maybe I will put it a proper line, let's say first, so that we can see the sequence later. So first will appear here. It means that it is going to our this output screen, that is SCD output, that is frame descriptor number 1. Fine, perfect. Let me redirect it to some file. What files available here? I have, let me redirect it to, let's say, file 2, and see that file 2 contents. Did you notice one thing? Now it is not appearing in our screen. So it has been redirected to this file 2. It's a file 2. So let's provide another second to file 2. File 2, then if you again see the file 2 contents, second as overwritten on the first one. But if you need a sequence, so what you can do, let's say try another third. So this time what I'm going to use with redirect with append. And if we echo the file 2, so second, third. Perfect. Now similarly you can use input, and in case of input, instead of keypad you can simply use something. It is taking from some file, that kind of input actually. That something like this, suppose uh, file to something like this, means this, in that case that arrow will be used from that one, correct. And Sorry. So pipe is you can think of it like something passing from one command to another command, and the pipe terminology, analogy you can think of similar to exactly what we use in plumbing. Hmm? So that pipe, we will see the use of pipe later when you will use the grab, but we can see at least this T use along with the pipe. So what happens if you take analogy of this plumbing? So this is our pipe, right one. Then left side, whatever you pass, it comes to the right side. Okay, and this is the T. So when we connect this T with this pipe, okay, or independently, so what it will do, it will uh, pass the same to two places, correct? Copy to two places. So one to so in our case, that one can be the standard output, another can be anything else. Okay, let's go there. Suppose if I use this time, let's say 4, and if I again use a pipe and then I connect this pipe with a T and write to file. So this time, did you notice one thing? In this time, basically what is happening, if I see the contents of file 2, so it is showing in that 4 overwritten, and here 4 is appearing in the standard output as well. So it means that 4 it has passed to two places, 1 and 2. So one to the file 2, second to the your standard output. So that is the use of this. So suppose if you want to use T and still you want to append something, so what we can do, you can use we have to provide some gap here, should work. So 5 appearing here, let's see, file 2 for 5, fine. So in the root file system, we observe that itself has a number of utilities, libraries, applications like in bin folder, as bin folder. Okay, and to support the Linux based applications. So you may require often to search a particular file, whether it in your project, whether it is in some executable file. So there are some utilities. For example, you can use locate command. Let me try to find out here locate, and let's say test6 is one of the file I have. So it will locate that, but too many places. If I want further refinement on this, okay, I say no, it let search test6 which is in home directory of user Sanjay. Okay, so my name. So in this case, we can use pipe. So through the pipe, we will pass the output of this test6 to our pattern matching command, that is grab. And what pattern we are matching here? Sanjay. So it will pass from first to second. Okay, then it will display those kind of thing. But again, right now, although you can see the file I am interested is there, but still because Sanjay is everywhere in the user, for the directory, so that is you may further refine it. So for example, you can put day itself here, or you can further grab, if you are aware that uh, inside somewhere, if you remember that okay, it may be some Linux related thing, or it is something in day, or let's say it was related to Linux related experiment. Further you can use, or you can just use Linux here also. Okay, but just I wanted to show you that this thing also. uh, so this time you can see it has used this Linux, the later one, because first one it passed to the second one. So that kind of thing. And so that also has, because it has passed that thing. Sanjay is also there, Linux is also there. Okay, let me see another one, or I can use that in the first state itself, day. Exactly one. Or simply, if I knew that, I could use day. That's it. Okay. So multiple step you can use the pipe, one place to another place command, or that command to say third command, something like that. Okay. So that is the pipe. And apart from that, there is a utility find that that is very interesting one. And because it is much it has many options for finding something. Let's say if I say find, and if only thing you might be knowing that particular syntax, or use that man command to find out that, and find anyway, like whenever you search anything that comes into the mind. Okay, find is find what. So you can use the root, from where you start your search, and then type whether it is a file or directory. It's file. What's the name? Let's its name is stat6. Okay, fine. Lot of stuff, because whatever even if permission denied, this that it was trying from the root, trying to find out the file from the root itself. So a lot of places it was not having the permission to access that particular file. So that's why there here comes that last block we discuss about our device null. What does that mean? It means that if we use the same command, and we know that what we are looking, this particular task6 file is user related, and I am the user. So there should be no issue in terms of permission. So let's ignore the error for the time being. So what we can do, we can pass that error file descriptor to redirect that error file descriptor to, instead of this particular our output, standard output screen monitor. So we have to redirect to somewhere else, but I don't want this junk in some file also, because I don't need it. So simply use our device null, which is nothing but our black hole kind of stuff here, that whatever you put there, it will never come back. So exactly it found that particular thing. So much better option of with the find. And grab, already we discussed the search pattern. And also you can use, let's say if you use suppose grab, I know for and recursive directory, and starting from this folder. So it will find that particular file, whatever we created, that contents of that for inside the file. So if you are going to find out, this is much stronger in terms of finding the particular pattern. Sometime if you have defined a variable or certain things, and if you are looking for the variable in your libraries, in C file or text file, wherever it is defined, then you can use this particular graph, and if required you can further filter that using the pipe, and then again using the grep command, that suppose if you are interested only a particular project, so you can put the project name. So that is the use of these kind of files. So there are multiple options, and you may require many times correct these things, and uh, so you may require many times these things with different options. So for that, always you can use man command. Let's say you are interested man graph, so you can find all other options with examples. Okay, so that is always there, and similarly for other command, and you can use help also. And if you want to know that where is this graph, so we know that we can always use type command. So graph is alias to this, which graph also another command we used earlier. It's in bin file folder. Okay, that's it. Now we understood that importance of the file system. It has everything which we require for our application, whether it is a binary, whether it is a system binary, whether it is some utility like graph, everything is inside this. Okay, but if you are going to make a special product, embedded Linux based product, that's where we are learning this Linux, correct? So what you need, a stable kernel to manage your resources, scheduling, all those kind of stuff, and certain number of files. Okay, if you want a very compact kind of your system, then you may want to pick your files yourself. So that is possible, very much possible. So for that, what we need to do, we need to create a file system from scratch. How to do that? Let's first create a file with the command data definition. So what it does? So data definition, if you take input file as device 0, this device 0 is not as in we discussed in the last block. This device 0 is nothing but a stream. It will generate a stream of 0. Okay, and what we want, this 0 we want to put in let's say my file 3, because 1 2 may be there, or this particular file. So we want to basically have one file which have all contents clear in the beginning. That's why 0. And block size we are interested 1024. It is a logical block size for the purpose of kernel, and count is 102400. Why? Because I need basically I need here, so that it will take less time. I just put 100 MB. Otherwise you can put 1 gig or whatever you want, depending on your requirement. So 100 MB means that 1024 1K into 1024 100. So 1K into 1K into 100, that is your 100 MB. Fine, 100 MB. And you can always check this file here. You know the stat command my file 3. So you can see that size and blocks. Blocks here, this blocks is not like 1024 0 because count we use 2400 because physical block will be 512 as I discussed earlier. But from this information we know that inode is this, this size is this, so definitely this is a file created in the hard disk with user Sanjay, group is also Sanjay. This is a regular file. Fine. Then what we need to do? Now we need to create it, make it a proper, this is simple file, we need to make it a proper file system. So let's say take example of extended file system, let's say extended to file system. So what we have utility make e2fs and use the sorry file 3 dot inz. Done. Okay, so sorry. So what happened now? We have this particular file system. So one of the requirement here to mount it now, this file system, like we root file system was mounted by the Linux. For mounting it and treating it just like a hard disk kind of thing. Anyway, the difference between this is a virtual file system. The difference between this virtual file system and this virtual hard disk image is only different that you can create the virtual hard disk base also based on this. Only difference is that you have to do partition there using some command like app disk and all that. Okay, but mounting will be required for virtual file system as well. So let's do this mounting here. Mount, and we have to provide that source point here. What is the source point? Right now I show you that I have created one temporary directory. I think it is already mounted. So let's mount temp. Something was already mounted there, and let me try to make it first unmount that. So nothing is there inside temp now. So let me now again mount sudo. It needs my sudo permission here. Then we have to put that particular source file. In my case, my file 3. We have to provide the mounting point, and we have to use this loopback device. What is the loopback device? As I told you, from that user perspective and from the program perspective, whenever you use any file system, so it is like for that application, it doesn't matter whether file is in this hard disk or file system in this hard disk or in some other device, correct, or in the network file system. Okay, so what makes is that independent of that, there is a loopback device called a loopback device. So that loop device we need to connect. Okay, so that's why this we are connecting using this. It has created this particular file. So let me try to create something. Now if I go inside temp, so by default it will have close plus pound folder. So in that folder anyway we will not see anything right now. Cannot because permission denied. No problem. We have sudo. Oh, sorry. Sudo should be properly used. Nothing is there. Okay. Let's create a file here. Suppose let's say test file inside that folder and type something and try to save it. Escape colon WQ quit. Oh, something wrong means what? Test cannot open file for writing. Press enter to type command to continue. Okay, so it is not allowing. It means there should be some permission issue. Let me come back without saving it. Quit without force quit. Okay, what may be the permission issue? Let's come back and see that our detail by default options with tab generally I use. Case here owner is root and group is also root. That is the problem. So I have two options. Either I use sudo and go to that, use the root privilege, or other option I can use chon for ownership transfer or group transfer. Ch group can be used. Okay, group transfer is not required, so only that chon I can use. So what I need to do, I need to take ownership to my username and temp folder. Again I will require sudo permission because you cannot change the ownership of root file without having sudo. And let me check it again. Yeah, now I can see that Sanjay username is there. So let me go inside the temp folder, again create some file, write something and try escape, try to write quit, done. So you can see test file is there, test file if I write, data is there. I can create my directory. Let's say bin. I can create my directory. Let's say as bin. You can see the right side also, correct? This because this is a mounted, so appearing as this graphical view also, correct? So that right now we have this. So similarly, we can create proxies and or etc or whatever folder we want related to file system and copy the stuff here from any other folder. Let's say if I copy this is the home directory and I had one test 6 or some directory was there Linux. They I think some day 3 or let me go up. We are searching for test 6 file or something. Day 3 test 6. Okay, Linux day 3 test 6. Suppose if I copy that particular file from there to this folder. Oh, now why? Just a moment. Something. Or it was trying to copy to the root. My mistake. To this. Okay. Fine. Test 6. So the way you can move to bin folder as bin folder. Okay. Nothing complicated here. So what we can do now? We can wrap up this, or we can unmount this our file temp, and again you need sudo permission for this unmount it. So if you see that file now detail my file 2.img, you will find some already the data size is there And what we can do, but to see the file inside this, we have to always mount it. Yeah, when as been right side you can see directly test 6 or here. Perfect. So this is the way for creating the file system. And so we discussed earlier in the root file system that device directory and device directory, when we were discussing, let's device directory. So device directory is having the nodes which user application can use to access the physical device. Perfect. So there is another folder. If you look into that system folder, you will see that devices folder is there. And if you go to the device folder anyway, it will show that block or character. If another block and character I told you, like buffered or unbuffered kind of devices. And here inside this, if you go to particular let's say PCI, so you will see like device, event, all those kind of things, power, event, status. So it means that for any device management perspective, this folder takes care of that, this system folder. Fine. And there is another folder that is called, and in this particular folder, if I use, let's say, LART, so you can see some file like u event is anyway this particular it is in this particular hard disk, because having this size is there. There is another folder called proc. So yesterday we identified, like in the proc, there is a we have seen that ls. If I see that proc, and we have seen CPU info, if you remember. So CPU info is showing, if I see the state of that particular file, size 0. How it is possible? Let's see that cat proc CPU info. So contents is there, but size is 0. Can you think what may be the possibility? Possibility is that because this is size if the file is in this hard disk, but this file is not in this hard disk, but is in the memory, our RAM. So that's why it is showing this. So most of that you will find that proc related file, process related, basically running information of the kernel. So this is what we have mentioned here, running status. So that is dynamic information which will be kept in the memory, and you can see directly there. So that's it for today. Thanks for your time, and please, if you found this useful, share this contents with the relevant folks. Okay, thanks.